Right, hello and welcome. This is Aurora with Supercharged Math, and today we are going to get started with some algebra. Yay! Hello, hello. Let's just make sure we are having some good sound. Give me a thumbs up, students, for sounding great. All right, thanks Elaine, thanks Amanda. Yeah, a little bit. I'm seeing some seesawing there. Yep, okay. So let's just make sure that we don't have any echoes. That would be the important part, echoing. All right, looking good, looking good. Excellent. Okay, I think we are just about ready to get started. Do you guys, let me think. Okay, so opinion time. I need your opinion. Everybody's got an opinion. They love to share it. Ready? I would love yours. So here, let me make my face all nice and big. There we go. Okay, I know that we've been doing a lot of content, and this is our session. This is session number 8, and we have 14 total. So my question is, would you like a review session, a live review session so far, or do you want to wait and have the big review at the very end when we get to session 14? So if you could drop me a note right now in the chat and let me know, do you want a mid-session and an end session, or just the one at the end? Let me know, because I'm not sure what would serve you guys best. So, okay, sounds great. So Amanda's having audio trouble. So Amanda, just let me, you should be able to hear me. So turn up your volume and so forth. And let's see. Oh, do you guys have your work submitted? Because I'm pulling winners next week for math prizes. So make sure, if you don't have them submitted, make sure you are submitting this week. And you know how you can take part of a science fair? Our math fair submissions are due this week as well. So make sure you get all the work that you would like me to see turned in, so we can put you in the running for being able to be eligible for a prize pool. Yeah? Okay, good. Okay, you can hear now. Perfect, excellent. All right, other questions, quick questions before we begin. I need some data from you, so you're also doing that for me, okay? Can you let me know if you have a pet, okay? And then let me know how many pets you have. So I'm just looking for data right now, okay? So if you have 10 fish, then you would just write in 10 fish, right? All right, so if you have a hamster and you got a big old, just give me a number. Just give me a number, okay? I'm looking for some numbers, can you tell? Okay, and then one other thing. I was wondering if you could tell me how many people are in your house. So you're giving me 2 different numbers, one for pets, one for number of people that live in your house. Just give me a number. That's all I care about, is just the number. Okay, great. I know, we need some data so we can do some graphing. Okay, great. How many of you guys liked the geography lessons last week? Did you like the geography? Did you get to it? Yeah, they're super fun, right? You actually can still access those. I put those in the same information that you're going to be accessing today. So if you missed geography last week, you have an opportunity for this week. Okay, excellent. Okay, good, good, good. Perfect. Wow, you guys have a lot of pets. Really? Wow, that's fantastic. All I have are children. I think do they count as maybe 2? You know, every time you count a pet as 1, if you have a kid, it's like 2, maybe 3. All right, I do have a story for today. I do have a story. All right, should we get started? It is officially time. Yes. All right, so keep putting your data in. It's so good to see you all. Hello. All right, let's go ahead and get started. Hello and welcome. This is Aurora with Supercharged Math. Today is our second session in graphing. So every session we are covering over a span of 2 weeks. So we started to introduce the idea of graphing with Cartesian coordinates last week. This week we're actually going to take it even further. So it gives you enough time to really get a good deep dive and understand, what are we doing and what am I going to use this for? So let's go ahead and get started. How many of you have graph paper? Those of you on Zoom, just give me a big old smile if you have something that looks like this on your desk. Do you have something like that? Maybe? Sort of? Okay. If you don't have graph paper, that's fine. I will go ahead. I know it was a little blurry. I will go ahead and just draw it out as if I didn't have graph paper, so it's easy to do. So it's easy to follow along. Okay, so let's get started with, this is probably I always say this, right? This is like the most important thing to remember. This is something you're going to be using in your science classes and in other classes that build off of this. So the ideas that we're going to be sharing in class today. Okay, so here we go. So what I want you to do is grab your math journal, grab a blank sheet of paper, and we are in graphing And this is part 2. Can I do part 2 if I missed part 1? The answer is yes. Okay. I want you to write this down. Y is equal to mx plus b. Okay, mx plus b. All right, write that down. And that's pretty much it. That's what we're going to talk about the whole time. So, okay, classed over. No. All right, so m, what is that? And b, what is that? Okay, those are numbers. They're just numbers. Could be 3, could be minus a quarter. They're just numbers, but they represent something. Do you recognize the y and the x? Okay, so these are variables. Okay, these are variables. And just like we've had equations before, these are also variables. Okay. All right, m and b are not. We call these things constants. If something is constant, does it change? No, it doesn't change, does it? It's constant. That's the definition of constant. So what I mean by that is it's a number. It's a number that won't change. So it might be a 3, and it'll be a 3 the whole time you do that problem, or it'll be a 6.5, or it'll be a 75 million. Okay, it'll be a number, but whatever that number is, it doesn't change for the whole duration of the problem. These things can change. When time t equals 0, you know, at the start, before your mom hits the gas pedal, she's going a velocity of 0. But when she hits it, and after 3 seconds, you know, her Tesla is now doing 104. So these are numbers that can change. These numbers do not. Okay, so why do we care? Because we are going to use this in our graphing. So m is known as the slope of the graph. We call that rise over run. B is called the y-intercept. And basically, it's just where it hits the x-axis. I'll write that down. Where the line hits or smacks into the, did I say x? I'm sorry, I meant y-axis. Okay. So those are the main ideas for today. So what do I mean? So if I have a graph here, and I have an x, and I have a y, and I have a line, do you see how it hits right here, the y-axis? So whatever that number is my y-intercept. My slope, m, is going to be what we call a rise over run. So if this is one point, and this is one point, you see how it went up a certain amount? Well, here, I'll choose a different point. You see how it went up a certain amount and over a certain amount? So this is the rise, and this is the run. And we express it as here, I'll write slope. We express it as a fraction, rise over run. Okay. So how much does it rise up, and how much does it run over? Now, it could run the other direction too. And we're going to take a look at how to calculate this, because this is how you get graphs put down as math equations on paper. So if you're doing an experiment, you'll often plot your data and then try to get a best fit line that'll fit that, and that way you can tell how those two things you were just testing with your science experiment are related. Okay, so there's a lot at one time, right? Okay, so let's just do it step by step. So here's my x and my y. And remember before, wherever we draw the x and y, that indicates the positive direction, okay? So if I put something over here, that's going to be negative x, because x equals 0 is where they intersect, and that's at the origin, okay? So I want to plot a point, and I'm going to let's start with an equation so you can see how this works. I'll put the equation over here. Y is equal to 2x minus 3. What does that mean? Okay, so where does it hit the y-axis? It hits the y-axis right here. So you start at the origin, and you go minus 1, minus 2, minus 3. X marks the spot right there. So we have a data point here at minus 3. So this is minus 3. Okay. If you have graph paper, you're welcome to use it, but otherwise you can just do like I'm doing. Okay. Now, this 2x. Okay, so what you do for the slope is you say, all right, this is a number. Whatever number is in front of the x, that is the slope. So the slope is 2, positive 2, and the y we call y-intercept is minus 3. So this is minus 3. Slope is 2. So you start at minus 3. Let me put some tick marks in here. Okay. And it says 2. Now, if I want to write 2 as a fraction, do you remember how to do that? Yeah, there's always a 1 hidden under here if you need it, right? 2 is the same as 2 over 1. Okay, so we're going to rise 2, 1, 2. We're going to run 1. Here's your next data point. We're going to rise 2. Oh, here, let me get a couple more. Rise 2, 1, 2. And we're going to go over 1. 1. Here's your next data point. And as soon as you have 3 data points, you can put in the line. We just graph the line. Okay, so then you can fill it in because a dashed line actually means something different. Okay, this is y is equal to 2x minus 3. Okay. All right, how do you remember where to put the x and the y when you're drawing a graph? Okay, so x is horizontal, always horizontal. So you can think like the sunrise, the sun, okay? So x is always the horizon. Y is always perpendicular to it. It always goes, points straight up, okay? When you get to engineering school, it's going to be different. You're going to be able to pick x and y to make the math easy. But for now, for when we are learning this, nail it down to one place and just keep positive x in this direction and positive y in this direction. Okay, so you're just going to have to memorize that to begin with. Okay, so x is always horizontal. Okay, so that's how we plot this equation. So where is my m? M is my slope. That was m. And my b is, don't forget the negative. Okay, b is here. All right, let's do more. So this makes sense. I know at first when you see it, you're like, I don't know about this. That's okay. Let's do another one. So draw yourself a new graph. Okay. Positive x is on the horizon. Y is always vertical. Okay. All right, now this equation is going to look like this. Y is equal to minus 1 over 3x plus 6. Okay, so there's our equation. Let's graph it. All right, rise over run. That's slope, but that's not where we start. The first thing we do is we look at this, whatever the number is that doesn't have an x with it, okay? So this is going to be my y equals mx plus b. Okay, this is my b. This is my y-intercept. Okay, so this says positive 6. So I'm going to go 1, 2, 3, 4, 5, 6, and it hits right here. Okay. All right, so it's right there. So that's my first data point. And you can tell this is true because look, what is the x value, or what are my coordinates right there? My coordinates are, here, I'll write it down here, 0, 6, right? X is 0. What happens to this equation when you put a 0 in for x? Yeah, this whole term goes away, and it says y equals 6. Do you see that? So we use, the intercept is whatever the y value is when x is 0. Okay, because we're not moving plus or minus on x. We're saying when it's 0, where does the line hit the y-axis? You see that? Okay, so now what we're going to do is m is going to be this whole thing. Whatever's in front of the x is going to be m. Now remember, m is equal to rise over run. Okay, it's our slope of the graph. Okay, so I have a minus 1/3. Okay, so what does that mean? So take the minus 1. So put your pencil on the 0, 6. Minus 1 means, remember, it's rise over run. If it's minus, you're not going to be rising. You're going to be falling. So go down 1. And then the 3 means I'm going to go over 3. So 1, 2, 3. So I'm going to wind up right. Okay, here's where we were. And then we're going to go down 1 and over 3. So here's my next one. So down 1, over 3. There's my next data point. Okay. And then we're going to go down 1, over 3. Down 1, over 3. Down 1, over 3. Okay, and once you have 3 data points, you can draw in your line. And that's how you graph an equation here. And we're going to learn how to go the other way, where you have a graph and how do you get the equation. Okay. All right, so what is my slope in this one? What is the value of the slope? Yeah, the slope is -1/3. And the y-intercept is at +6. So slope is -1/3. If you remember the other one, it was a +2. Let's see if I can get them both on the camera here. Okay, +2. Okay, so which one, here, if I back up the camera a little bit, I can get them both. Okay, so which one is steeper? Which one would you be more worried about going down if you were snow skiing? Yeah, this one's steeper. Okay, that's because of the slope value. It's 2 instead of 1/3. And you'll notice the negative sign. The negative sign is what makes it, so if it's negative, it's going to go down this way. If it's positive, it's going to kick it up like this. Okay. So a negative slope means downhill cross-country skiing as you're going positive x. And if it's a positive slope, it means you're going to be taking the chairlift up. Yeah. Okay, but you'll see more of that when we get going. Okay, how are we doing so far? Let me just leave the whole thing right here for a minute. How are we doing so far? Give me a look on your face so I know how you're feeling. That probably would help. Good? Okay, we're going to practice. We're going to do a lot of practice. Okay, good. So let's do one where, here, let me zoom in a little bit more. Okay. So let's talk about one that looks like this. Y is equal to 5x minus 4. Okay, 5x minus 4. So far from algebra, if I gave you, 5x minus 4 equals 0, this wouldn't scare you. Like, you already know how to handle this. Now we have two variables. We're introducing the idea of having an x and a y. Okay, and now we're also introducing the idea of making a graph. Ooh, that's terrible. Can I rewrite that? Let me do that again. Okay. So there's my y, there's my x. Okay, so you guys are writing down what I'm writing down. Y is equal to 5x minus 4. Okay, so you tell me, what's the first step? What do we do? Okay, so y is equal to mx plus b. Does this help? This is what I want to do first. I want the number with no x. Okay, so this is a minus 4. So what does this mean? This means when x is 0, y is 4. So 0, I want you to plot 0, comma, negative 4. So 1, 2, 3, 4. It's right here. 0, comma, minus 4. So my y-intercept is minus 4, okay, because of that guy. And then that's probably one of the most common mistakes we'll see is the student will just look at the number and plot 4 up here and forget about the minus. Okay, then what do we do? Now we look at the slope. The slope here, I'll write it out, is equal to 5 over 1, rise over run. So you start at the y-intercept and you go up 5. 1, 2, 3, 4. Whoop, need one more. 5, and then how much do we go over? 1. Look how steep this is getting. This is a much steeper graph, isn't it? Okay, let's do it again. We're going to go up 5. 1, 2, 3, 4, 5. Okay, so we go up 5. And now we're going to go over just 1. Here's my next one. Okay, and then you can take a ruler if you like. Okay, and connect the 3 dots. It's a little hard to get them exactly right when you're on a page with no grid lines on it. Okay, and there is my graph. Super steep, right? Can you imagine trying to go climb that? Okay, so it's a positive slope. So as we go along the x-axis, it's going to be like we're climbing a mountain. If we're heading this way, if we're like a little person and we're running, okay, and we're running this way, it's going to be like we're running up a mountain. The bigger this m value is, the steeper the mountain's going to be. If this was 10x, then we would be going up 10 and then over 1, up 10 over 1. So this would be much steeper. If this was a minus, somebody's asking if it's a minus 5, it means we go down. So we would go down 5 over 1, down 5 over 1. So that means the slope would be down as we progress along the x-axis. All right, you starting to see maybe a pattern in here? Okay, so which one is the steepest? As long as this number here determines the steepness, whether it's an uphill or whether it's a downhill. Here, I'll do a downhill one. Whether this would be downhill, right? This would be downhill. And so that is determined by the minus sign in front of the x. Okay. If it's a plus, then it's going to be an uphill. Good. All right, somebody's asking, what do you do if you have a data table, not an equation? I love that question. Let's take a look. Can I move this yet? Are we okay if I move this? Yeah? Okay. All right, so what do we do if we're doing science experiments? And we get a data table, and we have to figure out, well, what is that equation? Okay. Well, the first thing is you need to do some science experiments, and those are fun, aren't they? Okay, so you're shooting off rockets, or you're making paper airplanes, and you have some data. Okay, so we have at 0, x, we have 2 in the y. And we'll get a lot of practice as to taking data, so you know what this means. 1, 5, minus 1, minus 1, and a 2, 8. There's our data table. Okay. All right, so the question is, let's graph it. How do we graph that? Okay, so the first thing I want to do is I want to find my general equation and write it down. Y equals mx plus b. Okay, so my slope is what I want to handle first. Slope is equal to rise over run. But if you remember, the rise over run is just the change in y over the change in x. So we're going to say it's, this symbol here means the change. Okay, so this is y2 minus y1 over x2 minus x1. What do I mean by that? Okay. This means that, do you see how I have a set of coordinates here, and I can plot that on the graph? Those coordinates, 1, 5, okay? And then I've got more coordinates. I have a minus, or here, let's pick an easy one. I have a 0, 2. Okay. So this is x1. This is, here, I'll write it up here, x2. That's nothing. This is y1. This is the number for y2. So this is data set number 1. This is data set number 2. Okay, so x1 is 0. x2 is 1. y1 is 2. y2 is 5. And then we use it in here. So we're basically just breaking down how did we do rise over run. So the change in y over the change in x. Okay. So let's take a look. y2 is 5. y1 is 2. x2 is 1. x1 is 0. What is 5 minus 2? Yeah, this is the easy part, right? Figuring out which one goes where. That's the part where you're going to spend the most time. 5 minus 2 is 3. 1 minus 0 is 1. The slope is 3. So what did we do? So we just took a look at these first two. We said, what did x change? How did x change? It went from 0 to 1. That's a change of 1. That's on the bottom. What did y do? It was at 2 and then went to 5. What did it change? It changed 3. Here's the thing, though. The 3 has to be positive. You can't say 2 minus 5 because it was here and now it's there. So we want to know, did it rise or did it fall? If it started at 2 on a graph, it started at 2 and then went up to 5, then it rose, right? So that's going to be positive. Do you see that? Okay, so that's our M. B is, what is the value of y when x is 0? Can you look at the graph and tell me, or I'm sorry, look at the data table and tell me, what is the value of y when x is 0? Do any of those data points equal that? Yeah, this one, right? So B is equal to, you just write it down, 2. Yeah, because at this, when x is 0, this is the y-intercept. So we have a slope of 3, an intercept of 2. So my equation, y equals mx plus b, becomes, let me back up the camera just a little bit so you can see more of it. Okay, it becomes y is equal to m is 3, x plus 2. All right, so is there another way to do this? Yes, somebody was saying, couldn't I just plot it and then draw a line? Yes, you absolutely could. That's another way to do it. Absolutely, x and y. You guys are getting to the point now where you can there are multiple ways to do problems. And as long as you're careful, you'll still get the right answer. So this could be 0, 2. Okay, there's that. And then 1, 5. Oh, this is going to be a terrible graph because it's going to go like this. Okay, so it's going to look like this. Good. All right, what if there is no x equals 0 on the data table? Ooh, excellent question. You want to see how to do that? What if we didn't have this this up here? Okay, so if we didn't have that, this would be x1, x2, y1, y2. So you could use any two data points. Because it's a straight line, it'll still give you the same slope. But what if there is no 0? Okay, so what we do is we scoot this over a little bit, and we just take another, let's see, I want to put it here. We'll just take another one, and we'll say let's take 2, 8. All right, so then what we'll do is we'll say, well, y is equal to 3x plus b, because I already figured out the slope using these two, okay? Do you want to see me do the slope with just those two? Would that be useful? Yeah? Okay, let's do that here. Let me just get a new piece of paper. All right, so suppose we don't have that 0 in there, because that sure makes things handy, doesn't it? All right, x and y. 1, 5, -1, -1. If you're going to make a mistake on this, this is where it's going to be. It's when you have negative and you're trying to figure out the slope. So let me show you. So my slope is going to be y2 minus y1 over x2 minus x1. It's important that that second one be first. Otherwise, you'll get the wrong slope. It'll be pointed in the wrong direction. Okay, so this is data 1. This is data set 2. Okay, so this is x here. x1, x2, y1, y2, just so you're clear. Okay, y2 is -1, y1 is 5, so it's -5. Are you seeing this? Minus, and then you just put the 5. If this was -5, it would be minus a -5, which it's, here, let's see if we hear. x2 is -1, minus 1. What do we get on top? -6, and on the bottom, -2. Are you seeing how this is equal to +3? We get the same answer. It doesn't matter. Because it's a straight line, we will get the same answer. Okay? And, well, it's also because of the math. Okay, so how do we get b, though? There's no 0 value here. What we do is we take a third one, and we say y is equal to mx plus b, and we'll plug it in. Y is equal to 3x plus b. Okay, and then what we'll do, then we'll run out of room. There we go. And then what we'll do is we will say, let me use a bigger pen. Y is equal to 8 is equal to 3 times x plus b. Did you see that? So this is y, so I put it here. Y equals 3x. I put the x value here. So I'm just plugging in the coordinates. And you see how I have one equation and I have one unknown. So this is 8 equals 6 plus b. -6, -6. Okay. And then this goes away. 8 minus 6 is 2. So y is equal to 3x plus 2. Is that the same answer we got before? Yeah, it sure is. So what did we do? What did we do? Let's go back to the main page. Can I take this away? Can I take that away? Okay. So we had a data table. We figured out what our slope was by looking at how y changed and then dividing it by how x changed, rise over run. Okay. And then my b value is when x equals 0, which is right up here. When x is 0. But if we don't have that in our data table, which usually you don't, okay, it looks like this. So what you do is you find the slope by saying -1, -5. Okay, so we're taking this, so this one minus that one, divided by this one minus that one. Okay, so rise, how much did it rise? And then how much did it go on the horizontal? All right, and then you just do your fraction math equation. And then to find b, what we did is we plugged in a third data set for x and y, and we put the slope in, and we solve it for b. And that gives us our final result, which is here. And that's what we were doing on this page. All right, so how is that? Does it make sense? Even if you don't feel like you could do it on your own, does that make sense? Does that make sense for it? Yeah? Okay. So I know it's a lot, right? You guys are doing real calculations, so you're gonna get a lot of good practice. All right, there is something else that your workbook is gonna touch on, and I wanted just to briefly describe it. Do you remember how I kind of said in a undertone, I was like, oh, and you could just put a dashed line. Oh wait, don't make it dashed, because that means something else. Let me tell you what that something else is. Okay, so if I were to say to you, well, you tell me, who drives faster, mom or dad? Who drives faster in your family? Or grandma? This is where it gets fun. Aunts, uncles. Yeah, okay, definitely dad. Okay, grandma's not allowed to drive because she drives too fast. That's an interesting answer. Okay, all right, so if you were to think about how fast they go and then how fast the speed limit is, would you say, okay, pick the person who is definitely in the ticket zone. So think about that person. Okay. So imagine you're driving with them on the freeway, right? And you pass, maybe it's 65. All right, so how fast are they going? Tell me, how fast are they going? 90? All right, it says 65, right? So up until 65, so could they get a ticket if they were going 64? Yeah, you can get a ticket for anything, right? But just go with me. No, 64, safe zone. All right, how about 60? How about 35? Sure, that's a different ticket, right? Obstructing traffic. Okay, but a speeding ticket. They would not get a speeding ticket if they were going 60. Okay, what if they were going 102? Definitely, right? They would be a red flag for a policeman. Okay. And that's for good reason, right? Because we don't want them hurting other people, causing problems for us and expensive and yes, and hurting people, right? Okay, so up to that point, they're safe until they get to the speed limit and anything from that point on in that region. Okay, do you remember the story I told you about the fighter plane that I had been working on? Okay, so that's what we're gonna be talking about now, inequalities. How do you graph inequalities? So so if I have on my line here, 65, okay? And if I'm going anywhere in this region, I'm not going to get a ticket. Where do I get a ticket if I'm in this region? Would you agree? So this is 65. Okay, if it's posted 65 miles an hour, if I'm in this region, I'm in trouble. I am eligible for a ticket. This one, I'm okay. All right, and depending on who's driving, maybe, this is my husband. This is where he drives. Yep. All right, and these are other members of the family. Maybe not quite as good of a driver, maybe. Or at least they have more tickets on their record. Okay, so what does this have to do with graphing? Glad you asked. There are 3 steps, and I want you to write these down so you'll remember, because otherwise graphing inequalities can get a little confusing. Okay, if I said graph that for me. Oops. Wait. I messed up, didn't I? And I'm out of stickers. Oh, wait, no, I'm not. I can put a sticker on that. I have 1 sticker left. Okay, there you go. Here's my X, here's my Y. Okay, how do we graph this? Okay, Y is greater than 2X. Okay, the first thing I want you to do, so write the steps down. Step number 1 is I want you to plot the equation with an equal sign. So y equals 2x. That's step number 1. Change this to an equal sign. Can we plot that? Absolutely. So how do we plot y is equal to 2 times x? Well, what's the y-intercept? Do you see how we're in trouble? There's no y-intercept. Okay, so if there's no y-intercept, take a look. If x is equal to 0, what is y equal to? It's also 0, isn't it? That's because there's no y-intercept. It's 0. So it's actually going to go through the origin. Okay, great. So, and then what do we have? What's the slope? The slope is rise over run, so this is 2x. So that means we're going to go up to 1, 2 over 1, right? Because it's 2 over 1. The slope, okay, rise over run, run. And then we're going to go up 2 and then over 1. Okay. All right. So this is where you're going to put a dash line. If this is a greater than or less than symbol, it's going to be dashed. If it's got that little equal sign underneath it, then it's going to be solid, okay? Because that means you can be on the line too. But in this case, it says, no, you can't be on the line, okay? Speed limit 65, so this is 66. If you go 66, you'll get a ticket. Okay, so that's the step number 1, is I want you to plot this graph. So we just plotted y is equal to 2 times x, okay? Because we have 3 data points, 0, 0, and this is 1, 2, and 2, 4. Okay, number 2 is you're going to test. That's test number 3. So then we actually did number 2. If greater than or equal to, if greater than or less than, use a dashed line. So we just did that. That was step 2. Step 3 is the test. We need to know which side we're talking about. Are we talking about this side? Or are we talking about this side? And you're going to shade it. So test. So you can pick a point. So I'm going to say, all right, x equals 2. Tell me, what do I do? What do I get in here? Y is greater than 2 times x is 2. So I'm just going to put 2. Y must be greater than 4. So that tells me for the data point 2, it says y must be greater than 4. Greater than means now we're going to shade. Whoops, I don't have my little shading tool here. Okay. So that means, remember, if it's greater than or less than, we're not going to get one answer. We're going to get a range. Like, what speed can it go? You can go any speed you want, as long as it's less than 65 miles an hour. You can go anywhere you want on this side, but you're not allowed to be on the line, and you're not allowed to be over here. Okay. So you can choose any number to test. A lot of times I'll choose the origin, but I knew the origin was, you wouldn't pick the origin here because it's on the line. Okay. All right, good. So you can also look at the equation. Y has to be greater than this amount of x, so that tells you that y is going to be bigger. Okay, but testing is a good way to go. All right, let's try another one. Can I move this? Are we good? Can I move this? Yeah? Okay. All right, let's do one more. You guys want a story today? Do you want a story? Ooh, I have a good one. Okay, let's do one more example. Maybe 2 if you'd like one, 2. Yeah, actually, let's do a couple more examples, just because this is an important area. Okay, here is y and x. I'm going to say y is equal to, no, y is less than or equal to minus a half x plus 4. Okay. So, do you remember step number 1? You're going to graph the equation as an equal sign. So that means y equals minus 1/2 x plus 4. Okay. What do we do first? How do we graph it? Do you remember? So we're going to graph it when it's an equal sign. So change this just to an equal sign. And now we know this. Y is equal to mx plus b. It's the plus 4 we're interested in first. Okay, so 1, 2, 3, 4. That's where it hits the y-axis, right there. So the y-intercept is 4. The slope, what is the slope? The slope is the thing that's right in front of the x, so that's minus 1/2. Okay, slope is, I'll write it again, rise over run. And again, if there's a negative sign, we're not rising, we're falling. So we're going to go down 1, and then how many over do we go? Yeah, down 1 over 2. Okay, here's our next data point. And then we're going to do it again. Down 1 over 2. Down 1 over 2. Okay, so, whoops, this one was a little high. There you go. All right, now, do I put a dash line or do I put a solid line? What do you think? Yeah, I use a solid line because it has the little equal sign under it. Okay, so it's going to be a solid line. All right. And the third one is you test. All right, which side do you think it goes on? Okay, you tell me. You're going to test it. Here, I'll write. I ran out of room there, didn't I? Step 3, test. Okay, you want to test x equals 0? That's an easy one. That'll make this go away. Y has to be less than or equal to 4. So do I test below, thumbs down, or above, thumbs high? Yeah, so if this is x equals 0, we plug it in here. Y is less than or equal to, this goes away, 4. What does that mean? Y can be any value you want as long as it's 4 or less. So we are shading here. Did you get it? Yay! Good, good, good. All right, give me a smile if this is making sense. It's okay if you can't do it on your own, but if it's making sense. All right, give me a thumbs up if you want me to do one more sample. You want me to do one more sample? Yeah, yeah, yeah? Okay, let's do it. All right, this one is y is greater than 3x minus 2. All right, here we go. Here's a y, here's an x. All right, step 1. Do you remember step 1? Graph it. We want to graph the line. So just change it into something like this. That's the first thing. All right, you're graphing yours and I'm graphing mine, and then we're going to compare. Yes? Okay, so I'll make that just so you can see it. Okay, so graph yours. Okay. Yep, where does it hit the y-axis? Okay, and then do your slope and intercept. Okay. You think you got it? No. All right, show me. Show me what you have on the camera. Zoomers, you can show me what you got. Okay, and we'll see how well it compares. And then am I doing, do step 2. Is it a dashed or is it a, which one? Draw the line. Is it dashed or is it solid? Okay, so draw it in. Okay, here we go. Ready? 3, 2, 1. How'd you do? Yes? Okay, so minus 2, that's right here. This is at 0, comma, minus 2. That's where it hits the y-axis. The bottom part is the y-axis because it's connected to the top part. All right, and then we started here and we went up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Okay, and so this was my slope equals 3 over 1. Okay, and then it's dashed because of this. Okay, if it had a little line under it, it would be solid. All right, which side? Which side do you want to shade? Let's test. You want to test the origin, x equals 0? Is that included or not? Test the origin. You tell me, is it included or not? Okay, right there. So we would rewrite this. Y is greater than or equal to, this term goes away, minus 2. Y has to be bigger than minus 2. So what does that tell you? Y can be any value as long as it's bigger than minus 2. Minus 2 is the intercept. So it can be anything over here. Yay! All right, so how's that feeling? How's that feeling to you? Yeah? Good. All right, you would like a word problem. Excellent. Yes, I have lots of word problems. And you know what? I've got your data that you shared at the beginning of class. Let me see. Actually, I have a question for you. So, wait, before we begin, where is it? There you go. All right, so we have been going for, we actually have 5 more minutes of class. Do you guys want me to do one more sample problem before we start? No? You're done? One more? I'm seeing some more head nods. Let me just do a simple one. Can you guys do it for me? Can you do it for me? Yes, you can. Y is equal to x plus 3. Can you graph it? Yeah, I said y equals x plus 3. Okay, and those of you who are more advanced, you'd like to do an inequality version, I'll write it over here. You can make this thing a less than sign if you want to do that. You pick it, whichever one you want to do. Okay, graph it. There we go. X. Okay. All right, where's my intercept? Okay, at 3, 1, 2, 3. How about right there? Good, that's my positive 3, which is right here, plus 3. This is 0, 3. And then what happens to x? He goes up 1 over 1, up 1 over 1, up 1 over 1, right? Down 1, down over. And somebody was asking about, what about negatives? It's just easier if you just do it positive right now until you get the hang of it. Okay? All right, for those of you who did the equal sign, we'll do that in orange. Okay, this is your line, and you're done. Those of you who would like to do it this way, you had a dashed line there instead of a solid one, and we can plug in the origin, and that tells us we have to shade the bottom. Okay, so if you did it as y is less than x plus 3, then you had the dashed line and you shaded the bottom. If you did it as y just equals x plus 3, then it was just the top line. That was probably confusing, huh? Good. All right. I have a number of you that have aquariums. A lot of you have aquariums, and I think that's really, really cool. When I asked what kind of pets you had, yes? So I have something that you might be interested in. Let me see here. Let's see. Where is it? It's right in here. How many of you you had problems with Zoom? Okay, so the Zoom, oh wait, you can't see me, can you? All right, so we did it. All right, you guys have to cheer, right? Yay, we did it. We did another math class, woo! Normally people take about 2 weeks with this topic, so we are 2. So we did last week, we introduced how to plot the points, remember that? And then this week is how do we draw lines? All right, and then we're going to get all fancy pants crazy with different kinds of lines, but that happens later in the kind of closer to December, where we're going to graph curvy lines, because that's even more fun. So yay! We actually use this all the time. How many of you like airplanes? Anybody like airplanes? And rockets? And anybody have like a rock collection? Anybody have minerals, crystals? Okay, so we use this all the time in science because we want to see how does one thing relate to another. And so that's what X and Y are. And being able to have linear relationships makes it really, really easy to be able to predict what might happen in the future. For example, if how many of you have parents have cars? Yeah, parents have cars, right? So they hit the gas and what happens? The car takes off, right? The more they hit the gas, the more acceleration you feel. Would you agree? So there's a relationship there. Okay, what was I talking about? Aquariums. Oh, you know what? I completely forgot. You guys are on a different week. Okay, so let's take a look at your assignments that you have for this week. We have, here we go, Algebra session number 4, and you are not seeing this, are you? There we go. Okay, so we are in Algebra session number 4. The parent video is at the top. Okay, so here is your assignment outline. These are the assignments that you can choose to do. So notice there are a lot. Your job is to choose the one appropriate for your level. So what level that is that? It depends on where you are. If this was brand new, like I've never seen this before, please don't give me anything else. If that's where you are, you're in the beginner level. And so I want you to work on your algebra workbook called Graphing. And so you get to that by going to Algebra. Do you see where it says workbooks? Okay, you should already be partway through this workbook, by the way. All right, because we started it last week. Okay, and so you're going to go to workbooks, and do you see where it says workbook graphing? And you're going to open it up, and you are going to work on your graphing workbook. And this is the part we had worked on before. And now we're going to add the more advanced part where we're starting to graph lines. Okay, and this is where we started our conversation today. Lots of practice on here. Anyone feeling like, oh, I wish Aurora would just do my homework with me. It just works better if she's there. Doesn't it? You ever feel that way? Like if the teacher could just sit with me and do the work with me, then I know I would understand it better. No problem. Got you covered. So scroll down on the page until you get to the workbook and it says workbook. There we go, workbook. So I will go step by step and work through the workbook with you. So if you need that, it's here, and we work through the entire workbook. Remember, you're not supposed to do every single problem on every single page. You're doing enough so you understand the concepts, and you can do it and get the right answers just about every single time. Okay, so smile. There we go. Okay, so how many of you like chemistry? We have a chemistry lab this week. So if you're interested in some chemistry, you get to download that lab and take a look at it. So that is available for you. And you also get to take a look at, where's the math assignments outline? There we go. Okay. Wait, no, this is for a different class. There we go. Algebra. So we have chemistry lab calculations. That's in our beginner section. So you get to take a look at some chemistry this week. And then students, anyone feeling like this was easy? This was too easy. Please give me something harder. Okay, if that's you, you can test out of the workbook by going to the last 2 pages of the workbook. And if you get all of them right, and you don't hesitate, you are now done with the workbook. You don't even have to fill out the workbook. Just fill out the last 2 pages. And then what you're going to do is you are going to dive into, do you see where it says linear relationships packet? Right there. You're going to do that. So that's your packet. So if this was too easy from today, and you're like, okay, refresher, I got it, and I tested out of the workbook, you're going to do linear relationships packet number 1. And there's also a whole lot of fun things you can do. There's matching up, there's lots of games. Choose your own graphing adventure. You got to be careful on that one because if you choose the wrong answer, you just keep going in a circle and you won't actually get anywhere. You know the books Choose Your Own Adventure? It's similar to that. And then there's also some review. So remember at the beginning of class I said, would you like a review? I actually have a review for you to do in here, but if you'd like me to walk you through a review, like live, I can certainly do that. So if you would like, because we're partway through algebra, we want to review, so because we're going to shift gears and move into equations that have more than one variable. So are you noticing we graph things with x's and y's today? This is a good bridge between last week and the weeks before. We just talked about like 3x equals 9, and you had to solve for x. Now we're going to have x's and y's in the equations and possibly more. So we're going to learn how do you solve it when things are tangled up like that. So let's review what we've got going on so far before we add on more content. So the reviews are all in here. There's a number of them. There's scavenger hunts if you prefer those. There's gallery walks, stations. There's lots of fun things for you to do. All right, and then if you're one of my more advanced students and you'd like to do more, there's geography that's included this week. And temperature and altitude, there's supernova, shock waves, there's exoplanets, there's astronomy things. That's all. You know who you are if you're the advanced students, and you have been enjoying those as well. So if you're looking for practical applications of when am I ever going to use this stuff, that's what the advanced labs are doing. Okay, so how was that? Good? Are we ready for a story? Yes, maybe a little story? Okay. Did we do the story of, oh, no, I don't think we did. Okay, so you guys, just show me, Zoomers, show me with finger number 1 or finger number 2. Do you want to hear about the diamonds, or would you rather hear about the lasers? Which one? Number 1 is diamonds, number 2 is lasers. So tell me what you would like. I'm seeing more diamonds. Slightly more diamonds. Oh, now everybody's getting on, turning their cameras on. Okay, so I'm seeing 1, 2, 3, 4. Okay, diamonds it is. All right. So here, let me show you. Once upon a time, there was a engineering student who had a roommate. And my roommate in college, she had been dating let's see if I can get a new piece of paper to draw on. She'd been dating for a couple of years, and he was really excited. He's gonna propose to her. So what do men give women when they would like to propose? Yeah, a diamond, right? Okay. And actually, because you're advanced, I'm gonna tell you the second part of the story that I didn't tell the other class. Okay, so here we go. So he's got the whole thing arranged, it's dinner at a beach, and I don't know if you guys know your own parents' stories about this, but it's always fun to have. All right, so he decides he's got this romantic, he's got his dinner picnic on the blanket on the beach, it's going to be at sunset, and And so he's running a little late, right? So he knocks on the door, and she's a little upset. And she's like, well, and she was pacing back and forth. She's like, maybe he doesn't love me. Maybe he's not serious. I don't know where this relationship is going. And so she's working herself up, really. And meanwhile, this poor guy is trying to like make it so romantic and so sweet, right? So he's got the diamond ring in his pocket. And so he knocks on the door, and I was in on it, and I knew about this. And so she answers the door kind of in a huff, and she's like, you're finally here, right? And he's like, uh-oh, right? And he's like, are you ready for our date? And she goes, I guess. And so, have you ever done that when, like, you know, you should be happy to see something, but you're kind of holding on to a grudge a little bit, and you're like, I'm not quite over it, like you're late. You ever done that? I'm the only one. Okay, so yeah, and we all have, right? Okay, so he's so excited. He's like out of his mind. He can't wait. And then he sees this attitude from her, and she's like, I don't know. And then he goes, I just can't wait. He gets down on one knee right in the doorway, and he opens the box, and he goes, will you marry me? And she's like, and she was ready to like get really mad at him, and she's like, are you serious? And he's like, yeah, we've been dating for like 3 years. You want to get married? And she's like, and later she told me, she goes, I was trying to buy time. I was still kind of feeling, and I didn't want to feel that way when I got proposed to. She goes, so she looks at the ring, and she goes, is it real? And he goes, what do you mean? Yes, it's real. And so she doesn't say anything. She takes the box, she takes the ring out, goes over to our long, full-length mirror, and she goes like this with the ring. What did the ring do to the mirror? Please don't do this with your parents. No, don't do. You are not allowed to do this. Okay, completely scratch the mirror. She looks at it and she goes, oh, because she was so sure it was like a plastic one, right? And so she turns around, she goes, yes, of course I'll marry you. Yes. He goes like, oh, thank you. So in the earlier class, we were just learning about decimals, and I had said, okay, what's the hardness of a diamond? And it was like 9.8. And I said, what's the hardness of glass? And it was like 7.2. So I was telling the students, which one, here, glass, diamond. I said, which one is harder? And they're like, I don't know. I said, which number is bigger? And they're in decimals, so they were learning how to compare decimals and stuff. So the diamond's harder, so that's what's going to scratch what? That's why the mirror doesn't scratch the diamond. How many of you have marble countertops or know somebody who does? Yeah. And if you're going to use a knife, it looks like it's a cutting board, doesn't it? Like the granite, the wood, the rock. And your mom's like, please use a cutting board. And you're like, why? What's the big deal? It's a rock. It's fine. It's because the knife has a mineral hardness. It's a measure of the bond strength in the atoms itself. So the knife has a hardness of about 5.5. And if this is marble, this has a hardness of about 3.1. You tell me who's going to win. The knife's going to win. And what are you going to do? You're going to gouge it, right? And that's also marble. That's why they use knives to make marble statues, right? So, and that's also why if you've ever like taken, it's also reactive with acids. You ever taken a lemon and put it upside, please don't do this, because you will make it will react with the acid in the lemon and make a permanent stain on whatever's acidic that is touching it. So marble is really, really high maintenance for that reason, because it's soft and because it's chemically reactive. So if you have something made out of quartz, if you have a marble that's quartz, countertop that's made out of quartz, and you use a knife, what's going to happen to your knife? Quartz has a hardness of about 7, and the knife is still at 5.5. Who's going to win? Okay, will your knife stay nice and have a nice edge to it? That's why you still have to use a cutting board, because you want to now protect the knife instead of protecting the marble countertop, because my guess is your parents have some nice kitchen knives, right? So otherwise it's going to dull the knife really, really quickly. So that's why we want to use something that's flexible, something that's bendy, usually wood cutting boards or plastic. Usually you don't see like sheet metal for for cutting boards. And that's actually why. So, all right, so there you go. The second half of that story is not actually of that story, but the second part of a diamond story is when I was at Stanford, And one of the students were doing all kinds of crazy things. And I've only just seen the beginnings of this, but this happened 20 years ago, 30 years ago, I don't know, whenever I was at Stanford. And there was a student, and I walked in, they had a huge, it looked like a world's most ginormous microscope. And what he was doing was he was layering one molecular layer at a time. He was depositing diamond material. And then the machine would come back, and then it would build it up again, and it would go across. And then it would get to the end, and it would go across, and it was like, building things out of Legos, just one layer at a time. He was manufacturing diamonds. And what was really cool about this is this had never been done before. He was one of the PhD students that was there with us. Is he had a sheet of this. It was really small. It was like maybe an inch. And he had an ice cube. And he goes, here, come here, watch this. And he could pass it right through the ice cube. Because what was happening, it wasn't cutting it, but diamond actually conducts heat really, really well. And so just the act of my fingers touching this, here, these are my fingers, right? My fingers touching it and holding it and passing it through, it was melting a path through the actual ice cube, which was so cool. And it would just come out the other side. But you could actually just run it through at about that speed. And it would melt its way completely through using the heat from your hands. So diamond has that really cool property too. We're seeing this now, manufactured diamonds on things like tools and stuff like that. And so it's starting to be more mainstream. But how long do you think it would take if you did one atomic layer at a time? Do you think that's really fast? It's really slow, isn't it? Yeah, so you'd be waiting a long time for that, which is why it takes 7 years to get a PhD from Stanford. All right, so yay! Okay, so that wraps it up for our lesson for today. We've had a couple questions. Let me answer them. If the assignments of the week I am behind in a different workbook, then you are working through at your own pace. So remember, this is a self-paced program. If you're doing the live classes, you're always welcome. But you can do whatever workbook you're currently on. Just know that we have extra sessions for you if you would like them that are not synchronous. They are with Leah on Friday. So your time with her, you can ask her any questions about any part of the program at any time. And so we are currently working through live through graphing. Next week, we actually start linear equations, so systems of equations. That will start next week. And so you work through the program at your own pace. And do get your math assignments. They could be assignments from any part of the program that you're turning in this week, because we'll be pulling math prize winners at the start of class next week. Okay, yes, you can do the assignments. Absolutely. Okay, did it end well? Yes, they lived happily ever after. Okay, good. Can you please explain anything wrong with Zoom? If you had trouble with Zoom, can you just let me know, Aurora at superchargedscience.com. If you're on the live stream right now, I see a number of you can't figure out how to get to Zoom. Just scroll down. Do you see right under the chat box that you're using? It says connect to Zoom. So you click on that and make sure you understand that, well, that was a weird, awkward way to put that sentence, sorry. So when you scroll up, here, do you want me to show you? So look, Zoom will not open in, let me get the live stream going. So Zoom will not open in its regular Zoom app. It opens in a browser window. And so I think that's what's throwing people. So here I am, I'm talking right now, right? I'm talking. And then here's the chat box. And do you see where it says click to join live class on Zoom? You click that and it will take you to a page that says click to join through the browser. And that's how you join Zoom. You click that, you enter in the screen name that you want, you turn on your camera if you want, and then it opens in the browser. So it's not using its Zoom app, which currently is full of bugs and has all kinds of problems. So we are using the browser, which has corrected all of those problems, which is simply amazing. All right, does that help? Yeah, does that help? Okay, good. All right, so other questions? It won't let me use video. Not sure. It should be here. Do you guys want to troubleshoot a few Zoom things since we're at the end of class? So, so Tristan, you're saying that it won't let you start your video? Okay, so go ahead and start. Let me see if I can find you. Let me see. Yeah, you should be able to start. Okay, so Tristan, you want to start your video. The screen keeps freezing and stopping. So if you don't have a good internet connection, then you're going to have some problems. So you can try the live stream if that's better. Yeah, Yeah. Okay, here, let me run through a couple of these other questions. Other questions, you had problems with Zoom as well? Okay, so yes. If you're still having trouble, do you guys want to try it right now? And I'll just stay here. Here, we'll stop our other broadcast as well. All right, for the rest of you, I will see you soon. You've got plenty to do this week. Doug is going to see you on Thursday, and Leah is going to see you on Friday. All right, so we're done with class. So you guys are off and running with your assignments. I'm just going to stay here and help a couple of students that are having trouble with Zoom. So Christian and also C are having trouble, and Sarah? Okay, bye. I'll see you soon. Bye-bye. Okay, and then Mac, you said you're having trouble as well. So do you want to try your Zoom. That's it. Okay, good. Okay, good. Mac, it looks like you're doing okay. Yeah? Yeah, you're jumpy for me too. If you try if you check your internet speed, yeah, if you check your internet speed, you can see if that's part of the problem. Okay. Ashley, Allen, yes, I can see you. Yes, you guys look great. Perfect. Good job. Okay, so I think it's been confusing for people that it's opening in a browser window. I think that was part of it. Okay, good. All right, so yeah, if you guys got Zoom to work here, I'll stay here for a few more minutes and help you troubleshoot. Yep, we're not doing any new content. That's fine. Is it Layla? Are you having trouble, or did you just do that with your screen? I can't tell if that's a pixelation problem or if that's just an effect that you're doing. Okay, Christian, it looks like you got on here. And it says your video is actually started, so you just have a black screen right now. Okay. Yes, I can see you. Excellent. And then, yeah, you're good. Okay, you can't see me. Okay. All right. So here, let me see here. Okay, yeah, so you are completely, so Christian, go ahead and stop the Zoom stream and then try it again. Okay. All right. There you go. Okay. Okay, yes, you have a pixel problem. I agree. You definitely have a pixel problem. I'm not quite sure. Could be an internet thing. Do you want to turn off your video and turn it back on? Layla, you want to try that? See if that fixes it? Okay. Thank you. We are glad to be back on Zoom. Yay! Have a great day. Excellent. All right. Tristan, I see you. Hello. Hi, Elaine. Yep, you guys look fine. So you're set. You don't have to stay on. Okay, looks good. We're just helping a few students troubleshoot so I can stay here and talk through things. Yep. And so if it's not working, you can try a different device. For some reason, Chrome was trying to autofill stuff, and that was causing problems. Firefox seemed to be a little bit better for those of you on a PC. Your screen is very colorful. I would agree. I'm not quite sure what's going on there. Here, you want to know how to test your internet speed? Sure, I'll give it to everybody. Internet speed test. There you go. You guys all want it? Here, you can try your internet speed, see how you're doing. Okay. Okay, you have Safari. Okay, Christian, did you get on? Let's see, not yet. Okay. Okay, you have Safari. Safari should work. You can try that one. What's the other one for? Because it's a browser, right? So it shouldn't matter because it's a browser-based app right now. Okay. Okay, Safari, Opera, I think was the other one. Is that right? Vivaldi. Okay, Chrome. You can try Chrome for Mac. Yep, you could absolutely do that. Okay, yeah, try Chrome. Chrome did give us some trouble just because it likes to autofill things, and it's really, really impatient. Like if the page doesn't load super fast, then it just gives up and says, forget it. And that's why the pages looks sometimes pages look squelched. Opera is, you could try it. It's different than Chrome and Edge. If I remember right, the bar is somewhere else. So yeah, just use some of I'll stay here for a few minutes. So just try some of the different options and see. Tell everyone to use the little lock button next to refresh and then hit camera. Okay. So here, if I join via browser, it'll click and it'll look like this. And then I'll join via browser. And then if these things here are spinning, here, let me make it bigger. If these guys here are spinning, click on them. And then they'll show you. They'll be able to show the mute and the record button. But if there's nothing here and they just show the little spinny guys, little spinny rings, click on them. And then that should stop the spinny thing. I know. I just wish there was like one browser and it worked. And it just worked for everything. Wouldn't that be nice? Okay. All right. So, all right, Christian, you've got, looks like you're here. Okay. And it says your video is on. Okay. Yeah, do you want me to stay here? I'll stay here for about 4 more minutes. And then I have another thing I've got to go to. So, yeah, and then you can say start video. You see how it turns into a spinny ring? And it's probably going to not like that because I'm using all my cameras right now. So, yeah. But if it's a spinny ring, just click on it. Okay. And you can choose which camera you want. I have a lot of cameras. Okay. And then if it's not working, you try to join and it's not working, then I'm not going to click join now because we're going to do that. But you should join. Just click join and you'll join it. Okay. All right. But at least, Christian, you're here. Even if your video, for some reason, is not working. But you're here. You got in. So that's great. Something's wrong with your computer, Mac? Yeah, you could probably just try rebooting. Yeah, I know. They're supposed to save us all this time. And they do. Until they don't. So when I first started, I was telling somebody this the other day. Here, I'll just chat while we're waiting. Everybody was on the phone. So I started doing online classes in 2012. So this was way before. This was before there was like video. And what we would do is we would have a phone number. And so kids would dial in on the phone number, and then I would give them a PDF, and that would be the slides. And I'd say, okay, now go to slide number 3. And now, okay, now we're going to talk about that. Okay, now, and if they had wanted to talk to me, I'm like, okay, now the lines are open, and we'd all be on the phone. And hit *6 if you'd like to talk to me. Now, okay, now when you're done, make sure you mute yourself, hit *6 again. And so we've been doing this a long time. And the technology for the phones was so much better than the video because there's just so many options. Before it was just a phone, right? This is before cell phones. So yeah. Anyway, but it works, right? So as long as you can see me, and that's fantastic. And if you want to be on Zoom, that's great. But if your video doesn't work, maybe troubleshoot that with a different Zoom. So we're going to be doing this again on Wednesday. And then remember, Leah has her own Zoom and on Friday. So she's got a different Zoom. Okay. So, you can't see me. You can't see me. So Zoom is just not connecting the video. And I'm not sure why. What happens if you tried Chrome? Is that right, Christian? You tried Chrome, and I can see your chat. Okay, Ryder, hi, I see you. Tristan, I see you. It's Christian that we're having trouble with. Okay. So did you try a different browser? Okay, click via browser on a different browser. Okay, and your camera's not being used by something else? Yeah, I know, troubleshooting is always fun, isn't it? All right, so I'm going to go ahead and sign off. There's an option to stop incoming video. Right, so that's if, well, that's an interesting idea. You think they might have that engaged? It's possible. So, yeah, all right, so I'll stay here for another couple minutes. You can try pushing some more buttons and see if you can get anything to work. Okay, so I'll keep this open just for another couple minutes. And then that's why we also have the live stream. So if you can't get it to work, we're on the live stream. So yeah. And you can see me on the live stream. Okay, we'll work on it. Okay, perfect. Great. We'll get this to work. We'll get it to work, right? There's only so many things that can go wrong. So yeah, you guys are miles ahead of the kids on this. And at the very end of our calls, there were thousands of kids on these calls back then. And at the end of the call, I would unmute everybody. And it sounded like the world was exploding because they would all want to say goodbye at the same time. And they're like, goodbye, blah, 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 blah. It was like all on the phone. And so, and then usually the kids would like to know because some kids would want to hang up because they didn't want to hear the phone exploding in their ear. And other kids just loved it, right? Yeah, so, all right. I am going to sign off. You guys have more than enough to work on this week. You're going to work on your algebra. You are in session number 4 in algebra. And it looks like I will go ahead and schedule a review session for next week sometime. It's too late for me to announce it to everyone for this week. So we'll do a review of weeks 1 through 4. Maybe we'll do that. We'll do it next week. And if that would be helpful, And we'll have kind of a party. You guys like parties? I have the party all ready for the end of the year. I'm like so excited. We have a couple of parties actually because I couldn't decide on a theme, so I have a few of them. All right, so let me see what I can put together for a review for you. If you have any other questions, let me know. Aurora at superchargedscience.com, and I will see you soon. Bye-bye, everybody.